Welcome to the learning series on scientific computing. Scientific computing is a collection of tools, techniques, and theories required to solve on a computer mathematical models of problems in science and engineering, fundamentally programming. You need to understand that our computer is just a glorified calculator. We initially had simple calculators and later calculators with multiple functions, and today we have this huge calculator which can process audio, video, games, anything, but is at the end of the day a calculator. Knowing more of a computer, you understand that this device understands nothing but numbers and does only what it is told. Nothing more, nothing less. And the moment your calculator starts to do more than what it is told, the rise of the machines. But please do not worry, we are not there yet. As mentioned, at the physical level, it is all voltages, low voltage or high voltage. What a computer understands is as 0 and 1, binary numbers. To a certain extent, the human mind can comprehend binary, but when it goes beyond a certain limit, the human brain is not competent enough to manipulate binary numbers. And so, human brain brought out certain sets of programs which convert human understandable language into machine understandable language. So in between we have certain sets of programs which we either call compilers or maybe interpreters, which convert human understandable language, which we generally call high level language, into machine understandable machine language. So processing happens in machine language, and it is the same compiler or interpreter which converts it back into human understandable high level language. To briefly mention what a compiler and an interpreter is, fundamentally they are the same, they translate. But a compiler converts the entire program in high level into a machine language in a single shot. An assembler, on the other hand, kind of converts line by line. So the chances of getting to know if you have made a mistake somewhere is slightly more if you use interpreters. Generally, programming codes or languages like C and C++ use compilers, while Python, MATLAB, Scilab, and other high-level programs generally use interpreters. Being an electronics engineer, you will also need to understand what assembly language is and what assemblers are. More on that when you come to higher semesters. As you grow up the ladder of the life of a software engineer, probably you would have to start as an entry-level coder or a junior developer. You would need to know or have good coding skills in any one language and a little bit of algorithmic knowledge as well. As you grow up the ladder, you would become more experienced with knowledge on 2 to 3 programming languages and particularly algorithmic knowledge. Further up the ladder, a software engineer would design and implement the overall architecture of an application. At an entry level, you will also need to understand the difference between an editor and an integrated development environment. We would use IDEs in general, but a serious senior software developer would be more happy with editors. Just as humans speak different languages among themselves, so can a human speak different languages to a machine. Java, Ruby, PHP, all being different languages with which a human can interface with a machine. In our particular application, we limit our studies to scientific computing languages like Python, MATLAB, or even Scilab. Python is also quite famous for its peculiar name. It has nothing to do with the Python. It just so happens that Python's author, Julio Van Rossum, was watching a BBC series with Python as part of its name while he was writing this code. The author wanted a small, different name and so chose Python. And why do we choose Python? Because Python is simple, powerful, safe, and robust. In our course, we would be using the integrated development environments called PyCharm and a little bit of Jupyter Notebooks. I shall leave in the description box down below links to videos which would help you install both PyCharm and Jupyter Notebooks on your computer. So let's get started with our Python programming journey.